Experiment number 8 that has to be implemented is ring counter and Johnson counter. So the aim of the experiment is to design and implement ring counter using 4-bit shift register and Johnson counter using JK flip-flop and demonstrate its working. JK flip-flop is not being manufactured now. So that is 7476 IC that is not available in market. So instead of JK flip-flop, we'll use 7474 IC, that is D flip-flop. So we'll design the whole ring Johnson counter using D flip-flop. Now coming to the explanation for ring counter. Ring counter is the type of counter. It is like a circular shift register. So the output this is a circuit of ring counter. So here if you see, rest of the connections are all just the same as serial in, serial out shift register. Only difference is the output of the last flip-flop that is being connected is given as a feedback line to the input of the first flip-flop or first register. That is what the connection for ring counter is. So it is specified here that we should use a 4-bit shift register to implement ring counter. So 4-bit shift register is 7495 IC, that is a universal shift register IC. It is called a 4-bit parallel access shift register. It has 4 parallel inputs, then outputs. Then we have a mode control here. Serial input is there, ground, VCC. Then we have 2 clock pulses. If we give to clock 1, it will enable right shift, and clock 2 is left shift. So this is the pinout diagram for 7495 IC. So coming to the connection, so according to the circuit diagram, 749 circuit diagram, the output of the last flip-flop is given as the input to the ring counter circuit. So if we see the circuit diagram here, this QA, QB, QC, QD are the outputs. So QD is the output of the last flip-flop. So that should be taken and it should be given as the input to the first flip-flop. So here since it is if you see rest of the circuit, it is serial input. I mean, it is like a serial in shift register. So we should give the connection to serial input, not to the parallel inputs. Now we'll see the circuit diagram. So this is the circuit diagram for ring counter. So here you can see QA, QB, QC, QD are the inputs. QA, QB, QC, QD are the outputs. And if you see here, from 1 there is a connection to QD. So QD is the output of the last flip-flop that is connected to the serial input, that is 1. Then A, B, C, D, there is no connection. Those are the parallel data input. Then mode control should be given 0. Since if we give mode control 0 to 7495 IC, it will enable serial data transfer. If it is given a high value, then it will do parallel data transfer. So now coming to the clock pulse. So clock pulse you have to use clock 1. If you use clock 1, then it is shift right operation. So we have to give clock 1, connection to clock 1, and there is no connection to clock 2, that is 8th pin. Then mode control is 0, ground as usual, VCC should be connected. This is how the connection is. Now this is the waveform that you have to verify. How you have to perform the execution is, after finishing the connection, switch on the circuit. Then if you see the circuit, there is a connection from 10 to 1. We have a connection from 10 to output LED. Other than that, there is a connection from 10 to 1. Remove that connection and give it to ground. Give it to ground. Give monopulse. We have to connect to monopulse. So give monopulse. Give 1 clock pulse. Give clock pulse until only 1 output is having a high value. Rest all should remain 0. Once that is obtained as the output, then connect back the connection that is removed from 10. So from ground, remove the connection back and give it to the 10th pin. Then give the clock pulse again. You will obtain this truth table. So this is how the output has to be verified for ring counter. Now coming to Johnson counter. So Johnson counter is a modified ring counter. Here what we do is, if you see the circuit here, see in ring counter from Q we have taken the connection. In Johnson counter from Q bar we will take the connection and we will give it to the input of the first flip-flop. So the register cycles through a sequence of bit patterns and the mode of Johnson counter is 2n. That is if n is the number of flip-flops that is being used. So here we have to use 7474 IC. 7474 IC is D flip-flop IC. So this is what the connection is. Now the rest all are the connections that is similar to serial in shift register. Now you have to give the clock pulse. Then preset and clear should be high. Both preset and clear value should be high. Now coming to seeing the output, if you see the pinout diagram here, this 1 CLR, 1D, 1 clock, 1 S, 1 Q, 1 Q bar. This all belong to first D flip flop. Then 2 CLR, 2D, 2 clock, 2 S, 2 Q, 2 Q bar all belong to second D flip flop. So make sure when you do the connection, you connect it appropriately. Then preset and clear. The preset or clear and set. Here it is clear and set, that is given in pinout diagram. It should both be high. Then Q bar we have here. So Q bar of the last flip flop should be taken and connected to the D of the first IC, the first flip flop. Then we have to use two 7474 ICs here in order to achieve a 4-bit Johnson counter. Then this is the waveform for Johnson counter. When you give continuous clock pulse, then the output, the same output will be obtained as such. There is no specific input and all is required. The output will be obtained as such. This is how we have to verify the output for Johnson counter. Thank you.